Hello and welcome to Void Electronics. In today's video I will attempt to fix this Tektronix 466 oscilloscope. Now this scope has a story, and this story has a nice part and a not so nice part. So the really nice part about this scope is the fact that it was sent in by a viewer who basically said that I inspired him to buy this exact same scope and experiment with it. And I'm really honored to know that I inspire others to have fun with electronics, because this is basically the main purpose of this community. Also, the not so nice thing about this is that the eBay seller claimed that it was working, and in the listing there was a picture of this oscilloscope that actually produced a trace, but it doesn't anymore. Which means that there is a chance that this was damaged during shipping. So yeah, let's give it a try. Now there are some nasty signs already, and I'm not sure if they show up on camera, but the chassis looks twisted actually, so it looks more like a propeller than a rectangular, which is really weird. Have a look at this side as well, because it's obvious with the naked eye, but I'm not sure if it shows up on camera. And it also doesn't stand straight on the table, so yeah. This was definitely hit really hard. Now this is really sad, because have a look at this thing. It's absolutely beautiful. The outside looks a lot better than mine. The protective screen is in pristine condition. Mine is really scratched, I don't know what they did with it. So yeah, I would love to get this working once again. Okay, so enough talking, let's fire it up and see if we can confirm what the viewer said. So far so good, we have two lights. I can hear the fan. So at least part of it is working, it's not completely dead. That's always nice. But we still don't get a trace. So there are many things to check here. First of all, let's check the intensity. Okay, this is not feeling great. I feel some resistance here, it's hard to turn. I feel like it's not turning as much as a potentiometer should, so this is kind of strange. Let's leave it like that. Okay, I don't know, channel 1 maybe. Vertical position does nothing. Vertical position of the second one does nothing. Horizontal position does nothing. Beam finder, this should bring the spot somewhere on the display. And it does nothing. Okay. I don't know. It's on auto mode, so it should produce a trace. Normal mode, probably not. Single sweep. Okay. XY mode. Once again, this should produce a spot. And it doesn't. So yeah, there is definitely something wrong with it. How about storage? Oh, that's really nice. We have a green screen. So this confirms lots of things actually. This means that we have an intact tube, we have filament voltage, high voltage, we have some bias, at least for the storage section of the CRT. So yeah, this is a good sign. So it's not completely dead. And let's not leave it in storage for too long, because I heard that this kills the tube. We can also feed it a signal from a signal generator. However, I'm pretty sure that it won't do much. Let's give it a try. Anyway, it's just a sine wave, 25 kilohertz, 1 volt peak to peak. It doesn't matter all that much. And whatever. 0.5 volts per division, DC coupling, we are on channel 1, and we can adjust the trigger and take it out of XY mode maybe. Trigger, positive slope, nothing. Trigger, hold off, normal, nothing. So let's double check the trigger settings. We are on AC, coupling, source channel 1. Yeah, oh sorry, it needs to be in auto mode, okay. Once again, channel 1, AC coupling. Yep, it doesn't do anything, which is strange. I don't know, it looks like the time base or the trigger circuit are not working, because under these conditions we should get a triggered light here. And I tested it on my working unit and we do have the light, so there's something wrong with it. So yeah, at this point I'm curious if you would have any other test ideas, because I ran out of ideas, so I will just open it up to see what's going on inside. If you have any other ideas for this point in time, please let me know in the comments. I'm really curious about this. And meanwhile, let's take it apart. Needless to say, this unit has high voltages inside, so I wouldn't recommend doing something like this at home, and if you do so, you do it at your own risk. So at this point I think it just pushes out. It goes out the front actually. And it's pretty much stuck at this point. I guess that's due to the fact that it was hit really hard during shipment. I'm not sure how to take it out. Maybe I'll try it like this, 1 centimeter at a time, or should I say 1 inch at a time, sorry. Because at Tektronix they didn't believe in the metric system. See? I just mentioned the word inch and it's already coming out. There we go. Yeah, I hate the fact that it's getting stuck like this. Yeah, that's it. So, as I told you, I also have a 466 and it was also broken. So I have some experience with fixing a 466. This is not the first one that I see. And I'll be honest with you, I was really intimidated by the amount of circuitry that it has inside. However, I still managed to navigate through it and find the root cause and fix it. And in this case, the first thing that I would do is just a visual inspection for obvious faults. And by the way, if you're doing this on your own, keep in mind that the vertical section is really sensitive like this without a shield. So in my case, it used to interfere with the desk lamp. And this would create a really weird ripple on the screen. And it took me hours and hours to debug it just to find that it comes from the desk lamp. So yeah, keep that in mind. And this is probably the board that interests us today, which is the trigger generator and sweep logic, as they call it. I have a feeling that there is something wrong on this board, based on the symptoms that we see so far. And also look at these cute tunnel diodes, I love them. They are some really interesting components. And in this case there is nothing obviously wrong, so we need to go to the next step, which is to check for the main voltages. So the main voltages are produced by this bottom board, which is the power supply section and interfacing board as they call it. And all the voltages have labeled test points around here, and they also have an upper side limit and a lower side limit in the manual, so you know what to expect. Let's start with positive 65, which is supposed to have a test point, but I just couldn't find it, so I looked at the schematic and it should be present in the emitter of Q1736. So I managed to identify a transistor, which is this one, and I will check for voltage right here, and it's bang on. Next one is plus 15. Let's look around. This one says positive 15 and it looks okay to me. It is within spec. How about plus 5? Plus 5 is right here, I think, and it's bang on. What about negative 8? Negative 8 is right here. Uh-oh, here we have an issue, so this one is missing. We have positives 730 millivolts or so. This is bad. Let's move on. Negative 15, it's right here, and it is within spec. And then we have positive 140, which is right here, and this one is within spec. So we need to investigate why the minus 8 volts are missing. Okay, so in order to troubleshoot the power supply, I think it's a good idea to have a look at the schematic, which is of course in the manual. And at first it may look a bit intimidating because once again there are lots and lots of parts here. However, if you look at one section at a time, basically every single section is your textbook linear regulator. So this one is powered by a winding from the main transformer. Then we have a bridge rectifier, which is drawn in a funny way, but it's still a bridge rectifier. Filter capacitor, of course. And then we have an op-amp that drives the transistor that drives the pass transistor. So this is the main transistor that does the regulation. And you may be wondering what the reference is for this circuit. Well, the reference is the positive 65 volt rail. And this is used as the reference because it has a Zener diode as a reference, so it is very stable. As you can see, this is the reference for the positive 65 volts. So yeah, the rail is used as a reference for other rails. And you're supposed to adjust it for exactly 65 volts. I think this is part of the calibration procedure. So the reference voltage ends up here, and the thing that sets the voltage is this voltage divider and the ratio between the two resistors actually. The nice thing about this schematic is that we have the voltages right here, so you know what to expect when you do some measurements. So let's check for the voltages around the op-amp. Now the first step is to identify the op-amp that is responsible for the minus 8 volt rail. And based on the schematic, the op-amp is U1762B. So this is a dual op-amp and the B section is used on the negative 8 rail, which is this one. And we also have to identify the transistors that are part of this circuit, and they are Q1772, which is this one. It says right here on the serial screen on the PCB. Then Q1774 is also part of the circuit, and it's this one. And we also have the pass element, which is Q1776, which is this one. It is behind this aluminium bar. So we need to check the voltages around the op-amp first, so right here. And we can start with the power pins. And since this is a bootstrap circuit, there is no way that the power voltage is right. Let's start with pin number 4. This is supposed to be minus 8. Of course, it's not minus 8 because the rail doesn't work. It's around 740 millivolts, so we knew that already. How about the positive rail, which is pin 8? So it doesn't say the voltage, but it's powered from 15 volts through a 5 volt Zener, so it should be 10 volts or something like that. it's 19, it's around, okay, 19.6, so it's way too high. I'm not sure why that is. Anyway, it is within the spec of the op-amp, so I don't think this should blow up the op-amp. I think it takes plus minus 20 volts or so. Let's check the other pins as well. The output is pin 1 and it should be at around 1.8 volts. I'm pretty sure this is way off. Let's see. Of course it is. It's at around 700 millivolts. Pin 2 should be at ground. It's grounded through a resistor, probably for bias current compensation. Yes, this is at 0 volts. That's okay. And pin 3 should be at 0 volts, of course, if the feedback loop works, because it has negative feedback, V plus equals V minus and so on, and of course it's way off, it's 7.7 volts, and this means that the amplifier is not regulating, so yeah. However, at this point it's hard to say whether or not the op-amp is blown or something else. And that's because at the output of the op-amp we have a circuit that could possibly clamp it down, and the thing about this op-amp is that it has short circuit protection, so you can safely clamp it. So maybe it's trying to go up to the positive rail, but it's clamped by the next transistor or something like that. Now we need to have a look at the voltages around the pass transistor too, which we know they are wrong, but we need to see basically what's wrong with them. So I'm not sure what the pinout is, and I'm not sure about the part number because the manual is pretty hard to follow. But yeah, we have 0.4 volts on the first pin, we have 14.5 on the second one, and 0 on the third one. So I guess this is base, collector and emitter, and the base voltage is way too low for this to conduct. It's around 400 millivolts. It's way too low. The collector is at 14.5 volts, which is okay. That means that the power supply for this rail is working and the emitter is properly grounded. So I would say that the transistor is probably okay, but it's not really driven into conduction. That's what I understand at this point. So we need to check the other transistors as well. Okay, moving on to Q1774. We already know the collector voltage because it's tied right to the output of the op-amp, but let's double check it. 0.7 volts, just like the output of the op-amp, and it's supposed to be 1.8. Something's definitely wrong around here. How about the base voltage? It is supposed to be 0.4. And it is 0.4. That's a bit strange. How about the emitter? The emitter is probably grounded. And it is. So yeah, the voltage at the collector is not right, which is the same voltage at the base of Q1772. So what about the other voltages around Q1772? Let's check the emitter. It's supposed to be 1.1 volts. 1772. The emitter should be the one with the tab on the case. So it's this one. 400 and something millivolts. So yeah, this is the one that drives the pass transistor. It was supposed to be 1.1, so this is definitely wrong. So let's see if it's getting any power. It's powered from plus 5 volts unregulated through a 100 ohm resistor. So the 100 ohm resistor is right here. We have 10 volts here, and after the resistor we have 10 volts So I would expect this to be lower, but anyway. No, sorry, actually by looking at the schematic, I think this is supposed to be 5 volts with reference to 5 volts, so it's 10 volts in total. It's a weird thing. On the plus 5 volt unregulated supply it says 10 volts. We have a marking on the schematic, so I think this is right. So there is basically no collector current here, since we have exactly the same voltage on both legs of this resistor, which indicates that once again the power transistor is not even trying to conduct. The circuit is not trying to drive it into conduction, which makes me believe that the op-amp is dead. That's because the op-amp has all the reasons to be saturated at the positive supply at this point, and that's because V plus is a lot greater than V minus, so this output should be all the way up to the positive supply. And we have plenty of voltage on the positive supply. At this point we have 19 volts. So yeah, this is probably dead, but since these transistors are socketed, I think we have nothing to lose if we check this with a transistor checker. So let's have a look at that as well. So yeah, this looks soldered, but they are not. It's out. So Q1772, place your bets now. I'm almost certain this is okay. It is. Q1774, I'm almost sure it's okay too. Yep. Now I also checked the power transistor and it tests okay. I just checked these junctions on diode mode. I think that's good enough. And I also want to check the negative 8 volt rail for shorts. So let's see. Okay, it says 50 ohms. This is pretty low. I'm not sure if that's okay. What about in reverse? And it's around 50 ohms in reverse. So it's pretty low, but it's not a dead short, so it could be okay. And also by looking at the schematic, I noticed that the negative 8 volt rail is used all over the time base and trigger board. So this would explain why we have no trace. So at this point I will place my bets on the op-amp. Unfortunately this one is socketed, so I think we can just remove it like that. Otherwise I don't want to think how you would change this, because it's a nightmare to take this board out. Yes, it's out. I have another vintage one, which is this one. I hope this one is okay. I have to bend the pins slightly and then it should go right in. Is this the right way in? I hope so. There are no markings on the PCB. I will review the video and if it's good I will power it up. So what do you think? Do we have the negative 8 volt rail back or not? It's time to find out. 3, 2, 1, fire. And we do. Do we get a trace? Intensity? Yes! It works. I think we fixed it. That's it. This was fun. So that's it for this repair. Of course, off camera I have to check all the functionalities and make sure that everything is fine with this scope. And now to conclude, let's think about the main takeaways from here. I would say that the main takeaway here is that you don't have to be intimidated by such a scope. And that's because even though it has lots and lots of boards and components, by having a systematic approach you don't care about 99% of what's in there. You just need to read the manual, do some basic troubleshooting to pinpoint the bad part, which is an op-amp in this case, and of course you need to do this on your own as opposed to changing some components at random just because that's what somebody on a forum said. So I hope that you liked this video and that it actually increased your troubleshooting skills. And if it did, make sure to subscribe and like this video. Also, I would like to tell you that Void Electronics is more than just a YouTube channel. Void Electronics is actually an online electronics community, so I also encourage you to interact on our Discord server. We have channels dedicated for university, troubleshooting, our projects, and so on. So if you're into that, you can find the invitation link in the description of this video. That's it for now. Bye.